when we do a chemical reaction or think about a chemical reaction or consider any kind of a change or project that involves chemical substances, we need to be able to count the number of particles, molecules, or atoms that are involved. But it's impossible to count those things one by one because there are just too many of them or they're too small. So we're very often in the position of having to weigh out a certain amount of um, a certain amount of a substance in order to know exactly how many particles we have. So in order to know the number of grams that are associated with a certain number of particles, we have to be able to look up the molar mass of an element. And to do that, we use the periodic table. Now, different publishers make different periodic tables in different formats. They arrange them in different ways, color them in different ways, and include different information on their periodic tables. We need to be able to find the mass of an element no matter what periodic table we're using. So for a particular square on the periodic table, the information about an element that's included might be very different from one table to another, and it's not always organized in the correct way. So we're going to use the element sodium as an example to find four important pieces of information about an element. So the first thing we want to be able to do is to recognize the name, and the name, of course, is a word, and that's almost always included on a periodic table. The elemental symbol is sort of an abbreviation for the element, and it gets used to write chemical formulas. Formulas would be very unwieldy if we had to use names. The symbol for an element always starts with a capital letter, no matter where or when you write it. And if there is a second letter, the second letter is never a capital letter. It is never capitalized. It is always a lowercase letter. And as you can see from this example, the symbol for the element isn't always obviously related to its English name. Sometimes the symbols for elements are based on their names in other languages. Another piece of information that we come across on the periodic table is the atomic number. Now, we don't need the atomic number when we're trying to measure the mass of elements, but we want to be able to recognize the atomic number so that we don't confuse it with the mass. The atomic number is a whole number. It doesn't have any decimal point. That whole number stands for the number of protons in one atom of an element, and that number of protons is unique to the element. Every atom with 11 protons is some kind of a sodium atom. And every single sodium atom has exactly 11 protons. There's a different number for each element. And so again, that's a unique identifier. Here's what we're really interested in, and that is the mass of the element. So the mass on the periodic table for an element usually does have a decimal point, and often there are several digits after the decimal point. That's how we can recognize which number is the mass. So this number is sometimes referred to as the atomic weight. It's sometimes referred to as the atomic mass, and sometimes referred to as the average atomic mass. Some textbooks will tell you that those are slightly different things. For our purposes, in our course, we're going to consider them all to be the same thing. Those are names for the mass of an element. And we'll hear about another one in just a minute. So the number for mass on the periodic table, mass would normally have a unit of measure when we were writing it down, but this has no unit of measure because it has two different meanings. So this number can be the mass of an average atom, the mass of one atom with the unit of measure AMU. An AMU is an atomic mass unit. An atomic mass unit is a special unit of mass, and it's used for very small particles like atoms and molecules. So we can say from looking at this periodic table entry that one atom of sodium has a mass of 22.990 AMUs. So the mass on the periodic table can also be the mass of 1 mole of atoms of the element written in grams. So looking at this number on the periodic table, we can say that 1 mole of sodium atoms has a mass of 22.990 grams. So if we weigh out 22.990 grams of sodium, we know exactly how many atoms we have because we know how many atoms are in 1 mole of atoms. So here's the conclusion. We can say from looking at the periodic table that the molar mass of sodium is 23.0 grams. You'll notice that I've rounded it off, and in our class, for our purposes, it is good enough to use the molar mass of the element with one number after the decimal place, one digit following the decimal place. So in this case, 22.990 grams rounds off to 23.0 grams. And that's how we can find the molar mass of an element.